corners recording sheet. So it should look similar to this, and you're going to have to draw in the stages that we have up there. So our first stage, we have 3 triangles, and so that is our stage 1. And you're going to write this in the upper left-hand corner of your notes page. And then stage 2, we have 1, 2, 3, 4 triangles. And then in stage 3, we have 5 triangles. So now we're going to go over to our table and fill it in. Stage 1, how many triangles did we say we had? We have 3 total pieces there. Stage 2, we have 4 pieces. And in stage 3, we have 5 pieces. So my first step that I always do to find out my rule is to see what my pattern is, or what is my rate of change in my Y column. So from 3 to 4, I'm going up by 1. And then from 4 to 5, I'm also going up by 1. So I know my pattern is plus 1. So if I know my pattern is plus 1, that's going to be my multiplier. So I'm going to do 1 times my stage number. Well, my stage number is 1 for the first one. And 1 times 1 doesn't give me the answer that I want, which is 3. So I need to add 2 to make it equal 3. Now let's see if this pattern continues to work. If I do 1 times 2, which is my stage number, plus 2, does that give me 4? Yes, it does. So that is my process or my rule. So let's do 1 times 3 plus 2. That gives me 5. And then I'll do 1 times 4 plus 2, which will give me my 6. And then I'll do 1 times 5 plus 2, which will give me my 7. And then for my 100th term, I'll do 1 times 100 plus 2, which will give me 102. So now I know my rule is 1 times my X number plus 2. That's my process rule. And that will give me my Y. Now, I know that would have been a lot easier just to keep going down, plus 1, plus 1, plus 1. But if we're trying to find the rule, you need to remember that whatever our pattern is going to be our multiplier. That's what we're going to multiply the stage by. So let's look at the bottom 4 corners. And it tells us to write an algebraic expression. Well, an algebraic expression means it doesn't have an equal sign. So that's just going to be our process or our rule that we use with the X. So we'll do 1 times our term number, which was X, plus 2. So that is our expression because there's no equal sign. Then we're going to write an equation. We know that Y is our answer, so we're going to say Y equals, and we know 1 times X is just X plus 2. And there is our algebraic equation. Now our explanation of parts here is the X and the Y. So our X is equal to the stage number or the term, whichever they choose to call it. And in this one we call it the stage number. And then our Y is our total number of pieces. And Y, if you remember, Y is always going to be our answer. Now we're going to graph this and say, is it proportional or non-proportional? So we're going to look at our first one. We have 1, 3, and then we have 2, 4, and then we have 3, 5. Now, we really don't have to graph the rest of them, but we can. and we can just draw our line. And if we draw our line, is it going to go through 0, 0? Remember, that's the first thing we have to look at to see if it's a proportional line or not. And if I draw this line, it is not going to go through 0, 0. So this would be a non-proportional line, because 0 would go through 2. Because if I put 0 in for x, it would be 0 plus 2, which would be 2. So it's a non-proportional line. Okay, let's look at another pattern. Okay, now we have a different pattern. We have a triangle with two cubes or two squares underneath it for stage 1. And then for stage 2, we have a triangle with 4 squares underneath it. And then for stage 3, we have a triangle with 6 squares underneath it. So let's write our total number of pieces into our table. So stage 1, we have 3 pieces. Stage 2, we have 5 total pieces. And in stage 3, we have 7 total pieces. So what is our pattern, or our rate of change from 3 to 5 is plus 2. And then from 5 to 7 is also plus 2. So we know our multiplier for our process rule is going to be 2. So let's do 2 times our first stage is 1. So 2 times 1, well, that equals 2. That's not the 3 that we needed. So we need to add 1 to make it equal 3. Let's see if this rule works for all of them. So I'm going to do 2 times my stage 2 plus 1. Well, that's 4 plus 1, which is 5, so it works there. So then 2 times my stage 3 plus 1, and that gives me my 7. So now I can finish out with 4 and 5. So 2 times 4 is 8, plus 1 is 9. And then 2 times 5 is 10, plus 1 would be 11. And if you notice, I'm still going up by 2 as my rate of change. Now my 100th term would be 2 times 100 plus 1, which would be 200 plus 1, which is 201. And then our rule would be 2 times my x plus 1 would equal my y. So remember, every time our rate of change is going to be what we multiply with. What we multiply our stage number to. All right, now let's look at our algebraic expression and algebraic equation. Remember, expression is without the equal sign, so it was just our process rule. 2 times x plus 1. Our equation is going to be what y equals. Y equals 2x plus 1. And then our explanation of part would be exactly the same. Our x is our stage number, or our term. You might see it called a term in other problems. And then y is our total number of pieces. Now we're going to graph this and see if this one is proportional or not. Now, if you remember all of your rules about proportionality, you should be able to guess if it's proportional or not before we even graph it. But let's graph it just to make sure. So our first point would be 1, 3. And our second point would be 2, 5. And then our third point would be 3, 7. And then we could do 4, 9 if we wanted to. And then we can draw our line. And if we draw our line, is this line going to go through 0, 0? It should go through 1. Because 2 times 0 plus 1 would be 1. So our 0 term should go through 1. So it's not going through 0, 0, and it would be non-proportional. And if you remember our other rule, if you add anything to our equation, not besides just multiplying, it's going to be non-proportional. So you should have known it was non-proportional just by our algebraic expression. So now tomorrow in class, we're going to do some more problems like these, and you're going to be able to do the table, the equation, and the graph.